For these two are, of course, not the state functions, because these two are operations which are performed on the system to alter its energy. Thus, state function or state variables are those properties of a system which depend only on the state of the system, but not upon the path by which system has attained that state. The other examples of state functions are internal energy E, enthalpy H, entropy S, and free energy G. The sign convention plus Q or plus dQ implies that heat has been added to the system, that is, heat absorbed by the system. Therefore, minus Q or minus dQ means heat lost by the system. Plus W or plus dW means work has been done on the system. Therefore, minus W or minus dW means work has been done by the system on the surroundings. Therefore, during expansion of a gas, dW is negative, and for compression, dW is positive. Plus delta E or plus dE means internal energy of the system is increasing. Hence, negative sign will imply its decrease. The third point is extensive and intensive properties. A property is called extensive if its value is additive. Thus, an extensive property varies directly with the mass of the system. Mass itself is an extensive property. The other examples of extensive properties are energy E, entropy S, enthalpy H, free energy G, total heat capacity, total volume V, number of moles N, resistance, etc. An intensive property is independent of mass. If a system be divided into many parts, then if the value of a property remains same in all the parts, the property is called intensive. The examples of intensive properties are pressure P, temperature T, boiling point, freezing point, density, hardness, molar volume, refractive index, surface tension, viscosity, dielectric constant, molar enthalpy, molar entropy, free energy per mole, specific heat, ductility, malleability, mole fraction, molarity, etc. Fourth point, thermodynamic process. This includes A. Isothermal, a process in which temperature of the system is kept constant. dT is equal to 0. B. Isobaric, a process in which pressure of the system remains constant, that is dP equal to 0. C. Isochoric, a process during which volume of the system remains constant, that is dV is equal to 0. D. Adiabatic, a process during which there is no exchange of heat between the system and the surrounding. Thus there is always a change in temperature. For such a process, Q is equal to 0. E. Cyclic, if a system having undergone a change returns to initial state, then the process is called cyclic. For such a process, we can say that total change in a state function is 0. That is, delta E is equal to 0. F. Reversible, a process in which all the changes occurring at any part of the process in the system and boundaries are exactly reversed when the process is carried out in the opposite direction. Its main characteristics are: number 1, it proceeds with infinitesimal rate so that it can be considered to proceed through succession of equilibrium steps, each of which is an equilibrium state. Second, driving force and the opposing forces differ with each other by an infinitesimal value. Third, maximum work is available through such a process. Fourth, it is in fact an ideal process. In actual practice, it is impossible to carry out a process strictly under reversible conditions. Even then, this concept is very useful for studying many other processes of importance.